Hi everyone. The topic of my presentation is a GUI design for composition discovery of view interestingness. I'm Xiaozhong Zhang. This work is done by me, my colleague Xiaoyu Ge, and my advisor Panos K. Chrysanthis. We are all from University of Pittsburgh. First, let me introduce the background of our work. So, nowadays, view data analysis tools like Tableau help the user to create views to find interesting insights from the data. A view is the result of the visualization of an aggregate query. You can see an example view in the bottom. So you can see that the view actually showing the average capital gain of female and male across different marital status. You can see that a view is actually using an aggregation function like the average on a measure attribute like the capital gain, and grouping the result by the dimension attribute like the marital status. So a view is interesting if it contains interesting patterns. In this example view, high deviation is the interesting pattern, meaning that the orange bars are very different than the blue bars. So in order to find interesting views, different kinds of utility measures has been proposed to measure the interestingness of a view. Some example like deviation, like just mentioned before, and the relevance is also important, measuring the relevance between the view and the user's analysis task. However, not a single utility measure will be adequate to determine the view interestingness, like the example below. So if a view have high deviation, but it's not very relevant to the user's task, it will have low interestingness. On the other side, if a view is very relevant, but it has low deviation, then it will also be not interesting. So you can see that the view interestingness are actually determined by a combination of different utility measures. And we call this combination the composition of view interestingness. So our work is just need to find out how the different utility measures are combined to form the final utility interestingness of view. Since our work is the final goal is to advance the view recommendation tools, so we want to first categorize the view recommendation tasks, so that in our user study we can ask a specific question for specific task to save the user effort. So that we design this categorized classification system for view recommendation tasks. And our classification systems has two dimensions. The first dimension is called the exploration dimension. So there are because analysis tasks, usually some tasks are exploratory, meaning that a lot of views are candidates for interesting views. Some of the tasks are targeted, meaning that only a small portion of the views will be candidates for interesting views. The second dimension is comparison dimension. This is very simple, that if a view only contains the aggregate values for one subset, then it is non-comparative. If it contains aggregate values for more than one subset, it's comparative. Like the example on the first slide, because it has two data subsets, the female and the male, then it is comparative view recommendation task. So these four combined, we have four categories for view recommendation tasks. So after talking about the classification system, we will also talk about the view measures that we have identified that are commonly used nowadays. The first utility measure is novelty. It measures how familiar is the view context to the user. So view context means that those information that not including the actual values in the view, like those dimension attribute, category, or like measure attribute, are all like view context. Relevance measures how relevant is the view context to the analyzed task. And consciousness measures how easy can the view be perceived and remembered. Diversity measures how different are the values in a view. Deviation measures how different are values between different subsets in a view. Generality measures how well can the view be generalized to the whole subset. So after identifying utility measures, we want to map those utility measures into our categories so that we can use specific measures for specific tasks in our user study. We can see that the novelty are usually involved in explorative tasks because users want to find as more views as possible, so they want to find the novel views which are not similar to previous found views. But for targeted tasks, we usually want relevance to be important because users want to pinpoint specific views. And for non-comparative tasks, because it has only one data subset, then the diversity, which means the value difference among different groups in one data subset, is important. But for comparative tasks, deviation becomes important because they are measuring the difference between data subsets. The remaining two utility measures are common among all four categories, so that after all we have identified 4 commonly used utility measures for each view recommendation task category. So after we identify utility measures, we will use them in our GUI. And this is an overview of a GUI. You can see it has 3 parts. Part A is view selector, which is used for the user to select the specific views to answer the questions for it. And the view inspector, part B, will be displaying the selected views. You can see that it will have the view as well as some additional information like the coverage information, which is not indicated, illustrated directly in the view. And the third part is the view evaluator, which user asks questions, which we will use the answers of these questions to try to find out the view composition, the composition of view interestingness. You can see for question 1 to 6, we will ask a specific question about how the user evaluates the view with respect to this specific utility measure. And question 7 is a question to ask the user to give an overall score based on her evaluation of the previous individual utility measures. Question 8 is asking the user to give a new score if certain utility measure has changed to 0 or to 10. This is used to find the deviation information so that we can be more sure about the composition form that we discover later. So after then we will introduce an example to illustrate how we could find a potential composition form for view interestingness based on user feedback in the GUI. We can see that we give an example feedback which contains 3 utility measures. For each measure, we actually can get 3 readings of view interestingness. And we can see that for 3 different utility measure readings, we can, for example, for novelty, the first reading of utility measure is user's answer to question 1, and the corresponding interestingness is user answer to question 7, because this 7 is based on actually all the utility measures, including the answer for question 1. Then the second utility measure reading is 10, because we ask if it goes to 10, what will happen to the utility overall score. And the corresponding overall score, I2, will be the answer for the red box, in the red box. Similarly, M3 will have a value of 0, and I3 will have a value of 4. So we have 3 pairs of readings for each utility measure. So that then we need to categorize the view utility into 3 categories so that we can formulate them differently in our composition form. Type A is a utility measure that influences a lot the view interestingness. We defined to be the difference between I2 and 3 is large, meaning that the view can change the utility measure can change the interestingness a lot when it goes from 0 to 10. It will also bring the interestingness to 0 if it drops to 0, so that the I3 should be 0. So we can see that one deviation is actually satisfy this condition. So it is a type A utility measure. Type B measure has moderate influence on the interestingness, so that the difference between I1 and I3 is moderate, and it will not bring interestingness to 0 if it falls to 0. The conciseness is the example for type B utility measure. Type C utility measure usually have small influence on interestingness, so that I2 and I3 is small and I3 is larger than 0. Novelty is an example for that. Okay, after deciding the utility measure types, we can try to draft our composition form. So we can see we have drafted this composition form in a multiplicative form, so that A, B, and C are representing different types of utility measure. We can see that based on this form, type A measures actually have more influence than that of type B, and in turn than that of type C, because you can just estimate the gradients between of I over different A and B and C. And another thing is that the dropping to 0 of A will also bring I to 0, while those of B and C will not. We can see that this form actually satisfies all the conditions we have identified in the previous slides. So it could be a potential view composition form, view interestingness composition form. In order to increase the flexibility of our composition form, we have designed a refined composition form, which we add exponents to those utility measures, so that to indicate those exponents indicates the change rate of the inference of the utility measure. We can see that if E is almost to 1, like this one for deviation, because there are 3 pairs of readings form almost a line, meaning that the inference of deviation is almost constant, like across its domain, because the inference, we define inference as the slope of the line. However, if the x is actually higher than the line of yx, then yz, we know that the inference of this utility measure will be larger in the lower part of its domain and will be smaller in the higher part of its domain. So vice versa, if it's like the x is lower than this line of yz, then the inference will be smaller in the lower part of its domain and larger in the higher part of its domain. So to give a conclusion, in this work we have created a classification system for view recommendation tasks, and we have used identifying the utility measures in a GUI to try to use this GUI to discover composition of view interestingness. At last, we give an example of how we can use the feedback from the GUI in user study to find a potential composition form of view interestingness. For future work, we plan to conduct a user study, and then we plan to collect and analyze the user's feedback for those questions in our GUI, and then we will try to find out potential composition forms for utility view interestingness, and at last we will share the discovered composition forms with the community, so that we can advance the development of view recommendation technologies. So that's all of my presentation. Thank you very much.